What is a triangular number and how do we construct triangular numbers? So if we put one dot in row 1, 2 dots in row 2, and 3 dots in row 3, 4 dots in row 4, and following the pattern, you can keep going forever. And in this way, we form triangular numbers. So if we only have one row, then we would just get one dot. And so this is our first triangular number. So we're going to pick the first letter, use the first letter of triangular and to describe the first triangular number and put a subscript 1. So there's only one row, and we count how many dots we have. There's only one dot. And if we take 2 rows, that would be our second triangular number. T represents triangular. Subscript 2 represents the second or 2 rows. So first row we put a 1 dot. Second row we put 2 dots. And we count how many dots we have. So 1 plus 2, we got 3 dots. And if we join these dots together, we can form a triangle. That's why we call this a triangular number. And in the first case, there's only 1 dot. It really does not form any triangular. So that's a trivial case, special case. So let's look at what the third triangular number is. So we need 3 rows, 1 dot in row 1, 2 dots in row 2, 3 dots in row 3. And we can count how many of them we have. And 1 plus 2 plus 3, that is 6. And if we join all these dots together, and first of all we make a triangular shape, and then we can draw another one here. That's also another triangle. So that's why we call these triangular numbers. And if we have 4 rows, and we get the fourth triangular number, 1, 2, 3, and 4. And so we can add all these together, we get 10. And again, if you join these dots together, we get a dot here, a dot here. So you can, let me use a different color. 1 dot here, 2 dots, 3 dots, 4 dots. We can join them together to get triangles. Okay, and we can keep doing this. And for the first one is easy to count. There's only 1 dot. But the second one, how do we get 3? We usually count the first row 1 dot, second row 2 dots, and 1 plus 2 is 3. And the third triangular number, first row have 1 dot, second row 2 dots, third row 3 dots. Or you can count by the lines, and you can 1 dot and 2 dots and plus 3 dots. You can also do it this way. And for fourth, and we can, how do we obtain 10? Row 1, 1 dot, row 2, 2 dots, row 3, 3 dots, and row 4, 4 dots. And when we add them, we get 10. Okay, so without drawing the picture, I can obtain the fifth number. We know it's going to be row 1, row 1 dot, row 2, 2 dots, row 3, 3 dots, row 4, and plus row 5. And you add them, you will get 15. And you can also construct in a similar way to get the 6th number and so on. So in general, if I have n rows, so we try to come up with a formula to make this thing easier, so we don't have to keep adding 1 plus 2, 3, 4, 5, 6, 7, and so on. So if we have n rows, what's going to happen? So we're going to go back to this example right here. So if we have, suppose we have more dots. I'm gonna just draw a bunch of dots here. Although I just draw 2, 4, 6, 7 dots, it doesn't really mean I only have 7 dots, because n is a number I cannot actually draw, because what's n? N is a variable. We learned in algebra class, we know n is a variable that can represent any number. So the first row we have 1 dot, second row 2 dots, third row 3 dots, fourth row 4 dots, and if I want to, how do I draw n rows? And I can't, because I don't know n is. So the dots here, really, they have many dots. How many dots do I have? Depends on what n is. So if n is 4, I will stop. I just have 4 dots. If n is 10, then I have to have 10 dots. So I can draw some like dots here, and to kind of represent them more here. This only means I have more dots. Exactly how many? We don't know. It depends on what n is. So we're going to, if we want to, this is the nth triangular number. And how do we obtain that? We add 1, row 2, row 3, row 4. And there are a bunch of rows here we did not draw, because we don't know how many rows are here. So they are omitted. So we're going to do the same thing, put a plus, dot, dot, dot. These 3 dots here represent the bunch of numbers here, and plus the last row in. So a common mistake I saw in the past was some students thought this only means, so warning here, don't think this as just 1 plus 2 plus 3 plus 4 plus n. Ignoring the dots. You cannot do that. So some students thought, okay, we just add all these numbers you have, that's like 10, and plus the last n. And that's not, this is not the same if I add dots here, and that's not going to be equal to that. You cannot ignore the dots. So what do you get if we do this? You would just have to know what are here. So you won't be able to, this really cannot be simplified. If you want to, we do have a formula. If you have learned a calculus class, we know 1 plus 2 plus 3 plus 4 plus 5, 6, 7. So the dots here represents a continuing pattern. It doesn't mean you don't have any numbers here. It's not just going to be these 5 numbers, 1, 2, 3, 4, and the letter n. There are a bunch of numbers here. So when you write it, it's just going to be this. But this can be proved. If we want to really add them, if you learn calculus, you know this can be simplified to n times n plus 1 over 2. So that's the formula. In this formula, there are no more dots anymore. So that's going to be much easier. So for example, how do I obtain the first number? I just plug into, without drawing the graph, I'm just going to plug this into the formula. So this is a Tn formula. N in the formula, n here represents how many rows we have, or nth triangular number, or you can say how many rows, how many rows we have. So we look at the first row number. If we don't draw the dots, the shape, we're just going to use the formula to generate that. So plug, because the subscript is the first, that 1, so I'm going to replace the letter n in the formula here with 1. So it's 1 times 1 plus 1 over 2. That can be simplified to 1, because 1 plus 1 is 2. 1 times 2 is 2. 2 divided by 2 is 1. Similarly, how do I generate the second T2? Replace n with 2 in the formula. 2 times 2 plus 1 over 2. And these two cancel, you just get 3. And the same thing here, you can generate, replace n with 3 times 3 plus 1 over 2, so can be simplified to 6. And T4 will be 4 times 4 plus 1 over 2. That can simplify to 10. Okay, this formula right here, if you learn calculus, you have learned this before. If you haven't, we will or even if you have learned calculus, do you know why 1 plus 2 plus 3 plus 4 plus dot 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 plus n equals n times n plus 1 over 2? We will prove this in the other video. And so here we're just going to use the formula to come up with a list of triangular numbers. So if you continue to apply the formulas, you can get a list of triangular numbers. We get 1, 6, 3, 6, and 10, 15. If we want to get 6, just replace n with 6. So we will get 21, and so on. So suppose we want to, the question we want to do is there's a proposition in the textbook. Every positive integer must be we must be able to write a positive integer as the sum of 3 or fewer triangular numbers. So this is a proposition that we can try to verify this. So if we are given a number, say 39, and we don't need more than 3 triangular numbers, we must be able to add them to get 39. So you can look at the list and we can find out there's a 3 plus 15 and plus 21. That will give us 39. Sometimes you may have more than just one way to pick numbers to add up to get the numbers given. So make sure you use less than or at most 3 numbers, triangular numbers.